Okay, so my brother came in and interrupted the last one. I've made like 30 takes of the intro alone. But it's Zelda. I'm talking about black holes because not only are they one of my favorite things in astronomy, but they're also one of my favorite things in science as a whole, and it's been that way since I was little. And I'm also still really salty that I missed the notes day on them. So first of all, what even are black holes? How do they work? How are they born? What goes on inside of them? And why should I give a fuck? Black holes are born when a super high mass star, like over 8 solar masses, dies and explodes into a supernova. Black holes are pretty much the corpses of extremely high mass stars. During this supernova, the core of the star collapses in on itself. In lower mass stars, this collapse is usually stopped by neutron degeneracy pressure. Neutron degeneracy pressure is when two neutrons don't want to get too close to each other, and they're like, stay back, basically. Do not come to my town.
So you are dirty fat man with beards? Do not come to my town.
When a black hole is formed, not even that pressure can stop the gravity. The gravity is so strong. Nothing can stop the gravitational collapse. And the core just keeps collapsing and collapsing in on itself until the gravity gets so strong that the escape velocity reaches over the speed of light. I just want to say that the escape velocity for Earth is 11 kilometers per second. The speed of light is 300,000 kilometers per second. The gravity of black holes is insane. Now, what happens to the core as it keeps collapsing and collapsing in on itself? Well, we believe that the core collapses into an infinitely small and infinitely dense point of singularity. However, the concept of a singularity is heavily debated on in astronomy because, well, it kind of goes against all of the laws of physics. But now for the big question, what goes on inside of black holes? I'm gonna have to let you down here because we don't know, and we can never know. Once anything in the universe goes past the event horizon, which is where the gravitational escape velocity reaches over 300,000 kilometers per second, nothing in the universe can escape, because nothing can go faster than the speed of light. The only way you'd ever be able to know what goes on inside of a black hole is if you fell in. And I fear if you fell in, you would die. So I guess right now, we can't know for sure what goes on inside of them. Now, why should we care about black holes? Why should we care about black hole research? It's not gonna affect us. Well, they're cool, whatever, and also they can really help us understand how our universe works and how physics works. And that's really important knowledge to have, I feel. A common misconception I see about black holes is that they just suck up anything in their path. They're just like a cosmic vacuum, and that we're gonna get sucked into a black hole one day because there's a black hole at the center of the Milky Way. We're all getting sucked in. No, not quite. You can actually orbit a black hole perfectly fine. Like, you can't get too close, obviously, but things can literally orbit black holes perfectly fine. Like, if our sun was replaced with a black hole right now, the only thing we'd notice is that it's a whole lot colder. The Earth would continue to orbit the black hole perfectly fine. Like, as long as you're past the event horizon and you're not falling in, you're fine. You can orbit a black hole perfectly fine. You're not gonna get sucked in. It's not gonna just come up and grab you and shake you for your lunch money. It has no interest in doing that unless you go past the event horizon and go into its town. Do not come to its town. The reason why things don't usually orbit black holes is because of the supernova that leads to a black hole's creation. Nothing's gonna survive that. Those supernova are extremely strong. Sorry I went off on like a little rant about that, but you can orbit them fine. They're not a vacuum, they're not. But anyways, how the hell did we come up with the concept of a black hole? How do we know they exist? This is a lot. about to say. The concept of black holes can be dated back to 1783, when English natural philosopher and scientist John Michell proposed the idea of dark stars, which would be an object so massive and so dense, with gravity so strong that not even light would be able to escape. The concept of dark stars did not fully catch on in science until Albert Einstein's general theory of relativity was introduced in 1915. Einstein's theory of relativity interpreted space and time as a fabric, and gravity was simply a warping of that fabric. Now, I'm gonna butcher his name, but German physicist Karl Schwarzschild was able to use Einstein's equation to prove that dark stars could, in fact, exist. A fun fact about this is that he did this work while fighting in World War I. That's cool. That's just really cool. Shout out to him. Another innovation in our understanding of black holes was made in the 1930s when Subrahmanyan Chandrasekhar proposed the idea of an infinitely small and infinitely dense point of singularity. However, black holes remained more of a mathematical curiosity rather than a real object until the 1960s. The first known black hole was Cygnus X1, which was discovered in 1971. Okay, I'm trying to record this, and my computer keeps on being like, you have to restart, you have to restart, you have to restart to update, and it's making me mad. Anyways, there is a lot we truly don't know or understand about black holes, because it is fundamentally impossible to really know what's happening past the event horizon of a black hole, as zero information can escape it, as I've said earlier. This causes a lot of debates in science over the properties of black holes, especially over the concept of a singularity. Debates over the concept of the singularity arise because it seems to go against all of our laws of physics. Basically, we know that black holes exist. It's just extremely hard to pinpoint exactly how they work and what goes on inside of them. Okay, I am recording in a different location, but I was editing and I realized I forgot to mention this. A lot of astronomers don't even consider the concept of a singularity to be real. That's how heavily debated that concept is, and a lot of astronomers have also attempted to make black hole models that don't have to include a singularity. But it's difficult because it's just so complicated, and the whole debates over the concept of a singularity also remind me of debates over the Big Bang, because it just goes against all of our laws of physics, all of them basically. And yeah, I believe that quantum physics models of black holes kind of help, but yeah, there's a lot of debate, and I don't believe that the debates are ever going to end because of the fact that we cannot know how black holes work. With stars or other objects in the universe, we can get an understanding, but with things like black holes or the Big Bang, as I mentioned, or multiverses, yeah, it's just, there's always going to be debates over that. And yeah, maybe one day science will develop to that point, but right now that is beyond our comprehension. There have been a lot of recent developments regarding black holes. On April 10th, 2019, we managed to capture the first real image of a black hole with the Event Horizon Telescope. This picture was of a supermassive black hole at the center of galaxy M87. This was insane! I remember seeing a bunch of stuff about it, and then people were like, it's such a lame picture. Well, shut up. Even more recently, astronomers at UC Berkeley, I don't think I said that right, discovered a star getting devoured by a rogue black hole. I'm personally really, really excited about the future of black hole research, and while I would love to be a part of it one day, I'm not the most talented at math, unfortunately, but it's okay. I love black holes. They're so cool. I just love astronomy, and I'm really glad that I got to talk about them for my final project, because they're my favorite thing. Bye!